Come on, Twitch. Tell me I'm live. Finally. All right, good. We are live, so I will go and tell the world about it. Right. Streaming Procjam. Gonna do some stuff related to clicking on planets. And paste. And there we are. Let's get back to it. Now, I'm not at all sure that we will be able to stream very well today. It appears that we're having a nationwide internet problem, at least Comcast and RCN. So who knows whether or not anybody can actually see my stream, or even whether or not the stream is running properly. But I'll still work on Procjam, whether or not anybody can see me, so we'll get started. Now, the first thing I want to do is it's time to implement our cache for our resolutions for our textures. This is something I want to do sooner rather than later for animation purposes. So we're going to pop this planet open, and we're going to implement some cache, and that's pretty easy to do. Pool rather. Public static texture 2D list. Now we can create a list of a variety of textures all in one giant list, or we can separate them out into different sizes of lists. But we'll go ahead and just use them here. We'll call it a texture pool. Equals new. And then we'll say public static texture 2D get texture. And then we'll pass in a width and a height. And that will return a texture pool if we can find it, and if we can't, it won't. So for each texture pool, each texture 2D pool in texture pool, if pool.width equals width, and it's Monday, and it's shortly after a change in time zones. I am sleepy as heck. So if we have both, then we're going to be returning this texture, but more importantly, we're actually going to have to remove it from the pool. Because of that, we're going to have to use a for int a equals 0, a is less than texture pool.count, a++, instead of this for each. Because you can't modify it inside of a for each. So if we find a texture that we like, we're going to remove it from the texture pool. And then we're going to send it over. That way we won't end up reusing textures from multiple people. Now, if we didn't find the texture that we needed, we'll just create a new one. New texture 2D, and then we'll pass it the width and the height. That way, we will be able to simply create a new texture. But right now, we're not returning the textures that we claim back into this pool. So this is all that'll happen every single time until we set that up. Now, one of the other things that we're going to need to do is set up a static variable for our quality. We're going to assign specific tiers, like LOD levels, for our sizes, and we're going to want that to be affected by the quality settings of the machine, of the program. When you boot the program up, you get to choose a quality level. So to do that, we're going to go ahead and set up a set of parameters for int and width based on that. So public static texture 2D get texture, and then we'll give it just the LOD level. So when we have this LOD level, I think that I really want to have it be an enum. So public enum texture LODs. And we'll go ahead and have full, half, and tiny. Just because I can never really remember whether LOD 0 is full detail or not. I can't remember which direction it goes. So we'll just use this texture LOD. This will also make it so that we don't accidentally cast anything into the wrong version of get texture. By default, int height equals, we'll go ahead and just say 0 and width equals 0 for now. And then we'll do a switch. Case full, width equals 1024. Break case, that's not full. Case texture lod.half, width equals, I can go with 1024 or with 256. For now, we'll just go with 256. And then there's tiny, which will just make it like a 32. And then down here, what we'll do is we'll get the quality level from the application. I can't remember how to get it. Quality level, quality settings, there it is, right? Get quality level, there it is. So this should return an integer value that's between, I believe, 1 and 5 by default. And so what we're going to do is we are going to adjust our LODs based on that. So switch quality level. Default break. I guess we don't even need to do that. If it's default, just fall right through. The only question is, I don't know. Pink Hair says, howdy, hello. The only question is, I don't know what quality levels are which. For example, is it 0 indexed at lowest quality, or I can't remember. We'll go ahead and assume that 0 and 1 are both low enough quality that they're both going to suck. And we'll just go ahead and divide the width by 4 for them. Case 2, width divided by equals 2. Case 4, width times equals 2. And case 5, width times equals 4. But that's not really a, those are probably going to have to be tested. To be frank, even if you put your quality level at maximum, I don't think that most people who see a Unity game pop up on their screen and see the quality settings, I think most people automatically set it to fantastic under the assumption that they'll actually be able to run it at fantastic. But the idea of having your planetary textures be 4,000 pixels wide, that might be too many pixels. I don't know. We may have to rein that back or something. Anyway, at the end, we're just going to say height equals width divided by 2. And then we're going to return a texture that we get with those values. There we are. And because of that, we can fetch all sorts of things, and we no longer need to do this. Now, the question is whether or not we are going to have the width and the height get determined algorithmically by something that we can control, or whether it gets set globally or something. For now, what I'm going to do is I'm going to use the local scale. So we're going to go ahead and have width and height be defined by the local scale of this particular object. Except for it's not even width and height, is it? It's LOD. So public int or public texture lod. And what we'll do is we will say that if the scale is if the transform.local scale dot magnitude is greater than or equal to 1, return best. So texture lod dot full. And otherwise, we'll just keep going down it here. So if it's a 0.5, 0.5, 0.5 or less, let's go ahead and bring it down to 0.1. Half. And otherwise, return texture lod dot tiny. But what we do, we have a lot of, there's a lot of moments where we ask it for the width and the height that we're looking for. And that doesn't end up working out very well in this particular situation because we're not actually getting the width or the height. So what we're going to need to do, change this get texture out for a get height, which is going to be the same thing, right? Except that it's not going to involve the height. So int height equals width equals, and then int width equals get width lod. I accidentally made this get height. I meant to make it get width. Right, there we are. So we don't need this height. And then we'll just return the width here. And then when we go down here into our system, we'll be able to grab those as just arbitrary values. So we'll just go ahead and return get width lod. And then here we'll go ahead and have public int height get return width divided by 2. Now the problem with that is that does involve some math, so I don't want to call that every pixel. So the only situation I want to be careful of is when I'm in a loop, I don't want to be calling it every single part of the loop. And you can see that's exactly what I'm doing here. So when we are doing that, then every single pass of the loop will probably result in more math being done. So what we need to do is remove those from this this loop and put them into a, well, we'll go ahead and optimize that later. For now, we'll just go ahead and make a note of it. Width and height should be cached if we see any slowdown. And we may see slowdown. I'm not really sure, but we'll find out. It's not a whole lot of math, but it is some that, you know, if we're at 4,000 by 2,000 pixels, it's going to be a lot of math. Anyway, what we're going to see here is that these planets and stuff are now going to have no width or height. Oh, I'll have to fix what I've coded here. Oh, that's not a fucking error, Unity. Oh, yeah. I've been getting a little bit of ribbing about the way that I swear. Yeah, I'm not particularly concerned about my swearing. I suppose if a lot of people complained, I would maybe be more careful about it, but I think that a lot of programmers swear. I've seen some people say that specific kinds of programmers don't swear very much on stream, but they are obviously watching different programmers than I am. So, where were we? Cannot implicitly convert to texture 2D. Anything else you want to say? No? Okay, good. So what we're going to want to do here is we're going to need to have a function for releasing all of our textures into our into the cache and vice versa. So public void release textures to pool. And that's also going to happen on destroy. So what happens when we do that is we take all of our textures and put them back into the pool. So texture pool.add height map. Come on, fingers. Stop randomly typing letters. And then paste, paste, paste. And we've got 4 of them. We got albedo, height map, metallicity, and emission. And then we're also going to want to have one for claiming all textures. And for that, we'll just do the opposite. Height map equals get texture. And then what we'll actually do is just pass it the LODs manually. I'm not too concerned about it. Albedo. I could optimize it so I didn't have to have that manually passed, but you know, who cares? All right, so what's going to happen there is that all of these textures are going to get loaded from the pool and then released to the pool whenever we want them to be released. So in order to have that actually look proper, we're going to need to replace our attempts to load them here with a simple load. So what we're going to want to do is say that if there's no height map, or if height map does not equal width, or if height map does not equal height, or if there's no pixels for some reason, then we're going to want to reload all of our textures. So we'll just call release textures to pool, and then we will call load all textures. Actually, let's go ahead and make load all textures automatically call release textures to pool. And then down here, we're also going to want to set these to null. So height map equals null, albedo equals null, metallicity equals null, and emission equals null. And lastly, we're only going to want to add them to the texture pool if they exist. So if height map does not equal null, do this. Otherwise, we'll have nulls in our texture pool, which would just be stupid. There's no reason to have them. That's not how you spell metallicity. There we go. So when we load all the textures, we release all of the textures, and then we load them back up. And then down here, we don't need any of this stuff. Perfect, right? One of the other things we can do is we could just set these up inside of load all textures. There's no reason for them to be outside of it, since it's always going to be synced up. But instead of width times height, we could just use the length of one of these pixel counts here. And the reason we'll do that is just because it'll reduce the number of references very slightly. A tiny, tiny optimization. It's probably not needed. In fact, it's really not needed, but there's no reason to avoid it, I suppose. So what we've got now is a fully functional set of methods for quickly grabbing texture pool information. What we don't have is a way to display that texture pool information. So in order to properly display it, we're going to need to create an editor that changes this planetary script over here, which is good. We're overdue. So down here, we're going to go ahead and create a new folder for editors and create a new editor. Now, I don't remember how to do this by memory, so, you know, I'll have to look some of this stuff up. But as I recall, I have to do using engine Unity. Why isn't it using? Okay, for some reason it's not auto-completing today. Using Unity editor, I believe, is what we're going to need, and then we need to descend from Unity editor. I'll just look it up. Hold on a moment. Custom Unity editor. The only problem is I'm not actually sure whether or not they're called Unity editors, or there's like lots of names that that I never remember. But I think this is just an editor. And then what we want to override is the on inspector, I believe. Yeah, override on inspector GUI. Now what we'll do is we will put our important things right at the top, and that's going to be a couple of things that we're going to want to do. So we're going to want a button, and we're going to want a line of text, neither of which I remember off the top of my head. Editor GUI layout dot label field, cached texture pool, and then the length of the texture pool, which would be planet dot texture pool dot count textures. I don't think I need it to be like any sort of complicated setting here, but I do want a button. Button. Who's got the button? Do I just do editor GUI layout dot button? Drop down button? No. I do not see a button. Editor.button? Editor GUI button. Adding buttons to a custom inspector. Ba-da-bum-bum-bum. Custom editor. Oh yeah, that's right. I have to put the custom editor type in here. Hold on. Custom editor type of planet. And if we want to have it run a button, we just use GUI layout. Okay, so there's like editor GUI layout and editor GUI and there it is. So we're just gonna go ahead and put in the button here. If GUI layout.button randomize, then we're going to want to well, we're gonna need to make this planet a planet. Planet p equals planet target. So if we click randomize, then p.randomize, and if we click run, then p.run. Exciting stuff. Basic Unity details. Mostly I did this because I want that texture pool information. There are some times when that might be more useful. And now you can see I've got randomize and run set up right here. So these are scaled to specific sizes. The hot planet is 0.5, 0.5. This is 111, and these are 0.25, 0.25. So that should neatly fall into the 3 categories that we need. So what we're going to do is we are going to go ahead and run this moon, but I'm going to put in some debug code before I do. Debug.log new texture created plus width wide. Otherwise, we'll be in here and we'll say texture pulled from pool width wide, right? So what we're going to do is we're going to grab this moon and we're going to just run it, right? Go over to console, run. I am running at maximum quality, aren't I? I am. Okay, so I just tried to create a full-sized moon because my quality level is a little high here. But you can see that what happened is we created that full width texture. And if we were to go and look at the moon close up in our blindingly bright inspector window, I believe it's obviously this one with its high detail lunar surface. So we got a little bit of a seam going, but that's fine. It's not really noticeable anymore. So basically that works fine, except for our default quality level is so ridiculously high that it's causing us issues. So we're going to go in and change. Is it in build settings? No, it's not. It's in player settings. I am in gamma. Shouldn't I be in linear? Isn't linear substantially better than gamma for this kind of thing? Huh. I don't remember. More importantly, this is not where the default running is. So if we turn this back on, well, blew it out. That's fine. That doesn't look nearly as good as gamma. Maybe it's just because I have different parameters on it. That's interesting. You would think that it would be... that's interesting. Someone who knows more about gamma versus linear should tell me which one I should use, because I can obviously just recalibrate and make it work. But none of that is the level of where we're going. You know, when we run it, there is some sort of setting in here somewhere where you will automatically be able to run it at a particular level. No, I don't see any way to do that. All right, well, in that case, what we're going to do is, for now, we're just going to set case 5 equal to times 1, just so that we don't have this problem for a while, and then I'll figure it out later. But we now have this issue where this moon-like pulled textures 24 wide. If we were going to, we could now increase the size of the moon to 0.5, 0.5, 0.5, and run it again. And you can see that now it is at 256 wide, and our texture pool is now at 4 texture. If we increase it to 111, and we run it again, clear this for a second, we should get it back up to 1024, and it should absorb the ones that we had in the pool. We should remain at 4 pool textures. Yeah. See? So our texture pooling is working fine. And this is important for games where you're going to run a lot of stuff. We could continually create and destroy textures, but that's a little bit rough, especially if they're on a low-end machine. It makes a lot more sense to cache them. So that's what we're going to do. We're going to go ahead and cache them. So with that in mind, we now have a full set of textures that get cached properly and all sorts of stuff. Now, there are lots of things we could do with these planets to make them look a little bit better. The surfaces are still a little unconvincing, but I want to focus on being able to click on these planets. So that's what we're going to do right now. We're going to go ahead and make it so you can click on them, which is easier than it sounds. But what we're going to need to do in order to do that is we're going to have to use a mesh collider on every single one of these planets. And the reason for that is pretty simple. We're going to need the UV coordinate. That's interesting. So let's turn off the main camera so we can see this a little bit better. So basically what it's telling me is that it doesn't like my convex mesh collider, which is interesting. That shouldn't... Must have less than 256 verts? Really? Or I could inflate it, but if I inflate it, then it creates this really, really bad shell. Like, that's awful. I guess we'll go with non-convex, and hopefully we're not going to run into any problems with that. So we're also going to go ahead and create one around the hot planet. We'll add the moons later. We're not in a big hurry. But we're going to want to have a new script that handles clicking on stuff. So we'll call it the Click Master. And we're going to just drop that on the main camera. Come on. Come on. There we are. Now the Click Master's job is going to be to wait for the player to click and then see where they clicked. If input dot mouse button down 0, then click. Thank you for auto-completing super aggressively. I wish I could change the autocomplete settings so that they wouldn't be super aggressive anymore. I don't know when that started to happen. I guess it was around 2000 or so. All of a sudden, every single one of these IDEs started to make it so that just typing would autocomplete anything. So it was like, I guess if you're really, really used to that, that might be useful. But the only autocompletes I want are when I hit space or enter. Just typing should give me what I'm typing, honestly. So when we click, we're going to go ahead and grab a ray and a collider. So raycast hit. Ray equals, we have a camera attached to this. So we'll just go ahead and say, require component type of camera. And then we'll go ahead and have a protected camera cam and protected camera cam get. If cam equals null, then cam equals get component camera. Return cam. Okay, so we're just going to use the camera that we're set with. we'll get a screen point to ray using our mouse position. And then we'll do a physics raycast. So if physics.raycast ray out hit. And then we'll just do a quick debug.log hit dot. And there's a lot of things that we can do. We can get barycentric coordinates, which is a handy way to do this if we didn't have UV mapping, but we do. We have UV mapping. So what we really need to do is grab the texture coordinate. So we're going to go ahead and say debug. Oh, I already got debug log. There we are. So that should allow us to click on planets. And it's the simplest possible clicking, right? So let's hit play. Don't have a camera turned on, do I? Let's go ahead and turn the camera on. There we go. You can see that it's quite bright here in our planet. So we're going to go ahead and just run to bring our planet into view here. That's interesting. There we go. That's really slow. I didn't expect it to be that slow. I have a sinking suspicion that we are running at an incredibly wide. Now it's only 1024 according to this. This is too slow though. That's an order of magnitude slower than it should be. Well, to be honest, we didn't even need to run it. Although that glowing is stupid, the UV coordinates don't change. But I don't know what's going on with this incredibly slow processing, because that's... Why did it suddenly get so much slower? Now, I know that I do have some optimizations I could do, and apparently at least one of those is now critical, so we'll go ahead and go back in and try and get that to work. Yeah, this is only 1024 by 512. It shouldn't be sizable, but let's go ahead and click here. You can see that that is at 1 and 0.6. Now the reason that it's at 1 is because I put the seam facing directly at me earlier today so I could debug a seam issue. So if we click up here, it should be like 1 and 0.85. 0.8. So, yep, this seems to work fine. Yep, seems great. All right, so that gives us the exact coordinate we click on, which we can then use to alter the textures. The only problem I've got right now is that that was really abysmally slow. So there are some things I can optimize, and it's clear that I should go optimize them right now. So one of the things we need to optimize is here in the process map, we're going to want to stop using width and start using some other form of width. For example, we can just use the albedo.width. Or we can cache the width, but albedo.width should be extremely fast as well. Let's go ahead and just cache it. Int w equals width, int h equals height. Actually, we'll use width and height again. Int width equals this dot width, int height equals this dot height. That way I won't have to worry about changing all the names or anything. So we'll just override the locals. Oh, we got several problems with height. That might be why this is an issue. We'll go ahead and tbh, 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 tbh. That was an interesting problem. I'm not entirely sure what sort of nonsense would have happened there, but that's fine. So let's go ahead and check and see what sort of speed we get out of it now. Array index is out of range, huh? That really shouldn't be possible. If index is less than 0, or Index is greater than processed pixels dot length. Debug dot log error. Somehow our index got screwed up at x, y, and return. Which means it's at exactly the height and width, which shouldn't be possible, because it should stop when y equals height and when x equals width. So it shouldn't be possible for it to actually hit that limit, which is strange because it wasn't possible. Somehow our index got screwed up at 0, 0? Processed pixels is errored. It must be here. This must be what's causing the bug. That's strange, though. That shouldn't cause a bug. That should be fine. Well, let's remove this and see whether or not it unbugs. Also, oops, since we are... hold on. Int size equals width times height. If height map pixels dot length does not equal size, then do this. Now the reason I'm doing this is because we can in fact just release and reissue the textures every single time we call run from now on. There's no reason for us to have this if statement, because now we don't churn through them at all. We just have it run fine, you know. All right, so we'll let that seep into the processor. There we go. And then we'll tell it to run one more time here. Recompiling that cleared out the textures we had in the texture pool, but that should be okay. So that worked. I don't see any issues with it. It was also not incredibly slowly, but the step size got smashed, probably because I screwed that up by having a run that crashed off. So we're going to go ahead and hit play. We're going to have to turn our camera on again. We're bright. And then we're just going to tell it to run, and we're going to see whether or not we get the performance that we should get. Yeah, I thought that might happen. Okay. So there's one more if statement we need here. There we go. Now our texture pool is 16 textures for some reason. That's interesting. That shouldn't have been. Oh, wait, hold on. We can't reissue every single frame unless we can guarantee that we get the same ones back. Yeah, okay, hold on. So when we tell it to run, we load all textures. But after that, in the processor, we don't. During the process map, we just stay on with the texture we've currently got. That's fine then. That's fine. And so let's run this and see what it has to say for itself. Oh, height map pixels. God damn it, you stupid idiot. For some reason, I got 16 textures out of that. I guess it's because the other planets do have textures attached, so when I did on destroy, they returned those textures back to the wild. Even though those textures were not created by an operation that I'm running now. This should be faster than that. Why is it so slow? Wow, that's slow. Okay, so None of the things I optimized mattered. It's still super slow for some reason. So here's where this happens. It does this every 16 Y passes do something stuff. But for some reason, it's incredibly slow. It could be that this planet is simply a slow kind of planet, but shouldn't be. I wasn't this slow yesterday. Huh. Well, let me take a look at our process performance if I can get a word in edgewise here. All right, so it looks like we got update.script run behavior update, update behavior update. Yeah, this is where all the processing happens, obviously. Pause, please. God damn it. That was too slow. I didn't realize it was going to walk me off the edge and I wouldn't be able to get any further back. Yeah. Well, I guess that's okay. We'll go ahead and try it with a moon-like since they are smaller and simpler. So with the camera off, we have very, very good performance. But we're going to go ahead and run it. And you can see it processing through right there. So let's take a look here. This blue that you can't see, there it is. This blue is theoretically the load that we are creating. And if we dig down, we might be able to see exactly what function. Log string to console. All right, so planet update is the one that takes the longest by far, as in it takes 1/3 of a second, and it garbage collects 1/2 meg. It's unsightly. But log string to console is the only thing that's actually being explored in there. So planet.update isn't apparently logging deeper than that. It's not, the process map is obviously what it's doing, but it's not giving us details as to what in here is taking all of the time, because it could be here or it could be here. So I guess what we'll do is we'll go ahead and grab some microtime values. Float time equals time dot just need the fixed time in the start of the game. Yeah, that's fine. And then down here what we'll do is we'll do debug.log noise effort, noise calcs, and then we'll pass it in the time minus time.fixedTime. And then down here we'll say time equals time.fixedTime again. And we'll do the same thing down here at the bottom. Visuals, blah. And we'll just see what that has to say for itself, because maybe that'll tell us what exactly has gone wrong and how to fix it. Let's turn the camera on. Clear, run. So these are running in 1 frame because they've got their step size set to 1 due to crashes. Let's go ahead and use the hot planet since it's a little bit smaller and it won't calculate quite as high a resolution. But as you can see, I stomped on all of these step sizes. Let's just go ahead and run this here. So that runs nice and fast at 512. That doesn't look like 512, that looks like 256. It is, okay. But you can see that runs fast enough that didn't even create a bump. So what we're going to do now is run the planet, the Earth-like. this should take roughly forever in a day, so we should be able to see where the slowdown really is. All right, so if we take a look, what we've got is noise calc and visuals are still all at 0. That must be a just a problem with the fact that these need to be multiplied by some large amount or something, because that's ridiculous. Something that's taking more than 1/3 of a second should obviously have a number there other than 0. Unless time.fixedTime only fixes itself once a frame. Is that like a system time? I think that time.delta_time might only time.fixedTime might only get updated once per frame. Real time. This is what I like. All right, let's try one more time. Once again, we have to turn on the main camera. We don't have to, but we should. All right, so we'll clear this out and hit run on the main planet. Chaboom. And then we'll hit pause. All right, so here we got noise calcs -851. Mr. Idle says, it took me some time to realize that you're working on planets. Yep, that's what I'm making for this game jam, planets. Pause, please, jeez. So what we've got here are what's going on with our full elapsed time. And you can see that it seems to be saying that although the noise calcs take 851 milliseconds, which is too long, it's the visuals that really take all the time, to the order of 3 seconds. So there's something in here that's taking forever, and it could simply be that applying changes to textures is slow. So if we wanted to, we could add in some better elements here. We'll go ahead and see here texture updates, and then down here we'll go ahead and have emissions. And we'll go ahead and keep winnowing down the cause here. If the texture updates are really slow, I can always update one texture per frame or something similar, but they shouldn't be 3 seconds slow. That's like hilarious. So what we've got here is noise calcs and visuals. There's no longer one that says visuals. Oh, I forgot to hit clear on play. I see. So here we have noise calcs, texture updates, and emissions. So it is in fact the texture updates that are taking 3,000 seconds or 3,000 milliseconds. So that means that something in this span here is taking up all the time. And it could very well be this alpha to normal. Let's go ahead and see whether or not it's the alpha to normal that's causing all the trouble. Yeah. Because I think that's probably pretty unoptimized, even though I tried to optimize at least some. What we're going to do is we're going to start paused. We'll turn on the camera. That way we won't have to worry about it doing multiple frames. And then we'll go here and hit run. I'm almost sure that it's this, yeah. So calculating out the bump map is the problem. And the reason that it's taking so long to calculate out that bump map Mr. Idle says, I actually waited quite a while hoping you'd attempt to tackle this topic. Of course, goals are not the most ambitious, but still. You mean, what topic? Planets in general? Anyway, the reason that the bump map is so awful is because it is trying to calculate out the entire bump map for the entire image, whereas everything else is only doing a step. So in order to have the bump map only calculate out the required step, we would want to have it do itself a little bit better. But the problem is that the bump map here is a 3x3 filter, meaning that it won't even start working until the third pass, or the second pass. So it's going to be impossible for us to do an update that actually just keeps track of each pass. So this scan and pan counter, oh, that's not where it goes. Here it is. So this scan and pan counter can limit us to a specific limited set of values, but it's going to be wrong for almost all of them. So what we may need to do instead is only calculate out the alpha to normal in the last set. So if scan and pound counter equals 0, then do the alpha to normal. That still means that you're going to have a long hang on that last frame. But let's go ahead and try it out and see what's up. Mr. Idle apparently really likes planets. Well, I recommend that you go back and watch me developing these, because I don't think you've, unless you are pretty familiar with this, I don't think you know some of what I've done here. There's a lot of fairly complicated noise field stuff going on. So that's the length of time I expected it to take. So that's still pretty slow in terms of the frames, but it's not unbearably slow. The problem is that there's then this long hang while it thinks about the normal map. So what I could do is I could actually wait until it's finished and then update the normal map in the same way, doing the slices, which is probably better than letting it hang. Because if I'm updating it in slices, then I would let it work out. So we'll go ahead and do that. We'll create a public render stage. Up here, we'll go ahead and put in a render stage, public enum render stage, none, finished, color or albedo, height. Oh, he was watching some of those streams, but then he decided to actually come by and watch a live stream. Wise choice. I'm much more interactive when I can see you. Hello, Asterion, and welcome to the show. We're working on a little bit of optimization. We've got clicking working, but before I make clicking actually do something, I want to make sure that rendering this stuff doesn't take 2 days. So down here in our render type, which is here, render stage dot none. And then what we'll do is here in start, we don't have a start, do we? We do not have a start. So we're going to go ahead and have a start. Public void start. If stage equals none, then run. Now the problem with that, of course, is that we currently have 4 planets running, so that might be pretty slow. So we're going to go ahead and disable some of these planets, just so that it doesn't get out of control. We'll turn our main camera back on for now, and we're going to want to have the stages start to be a little bit more interesting here. So here in run, what happens is if the application is playing, it goes by step size, but if it's not playing, it does this instant pan and scan and then comes back. We're going to want to duplicate all of this stuff for the height map. So we'll just create public void run height map. which will have these same details. And now if we are in this run height map section, we only want to do that when we are is playing like this. So in actuality, we're not going to need to do this part because that part's already done. If we're getting called, then the step size has been set up to be 1 or 0. So here we can just say, if application is playing, then do that. Otherwise, scan and pan counter equals 0. And then we'll do process height map. So down here under process map, we'll create a new function called process height map. I don't remember whether it had a capital M or not. Well, I'll figure it out. But basically, process height map will do the same thing as process map. And I've lost track of where things are going here. Run height map versus. So basically, the thing is that the run series is for queuing off the next step. So we only run the run series inside of. Normally we wait to run the height map until the main albedo has been processed. But if the main albedo is processed instantly, we then run the height map instantly. If the main albedo is not processed instantly, we're going to have to run height map as the last step. As the last step in our update function. So if we look for update, you can see here we've got span and can and pan counter minus process map. And here we're checking to see if it's greater than 0. So then at the end, we're going to say if scan and pan counter equals 0, then run height map. And that way we'll kick off the next height map. Inside of our scan and pan counter, we're going to want to fork based on whether or not we are running, which mode we're running in. So if stage equals render stage dot albedo, then do this. Else if stage equals render stage dot height, then we're going to want to process height map. That is also, this is going to be outside. There we are. So we are going to then have a final else debug.log. Why are we trying to render during stage? And then we'll give it the stage. So this is pretty straightforward, but we are going to want to have it so that it modifies the stages as well. Stage equals render stage dot height. And then down here, we're going to go ahead and say that if the pan and scan counter equals 0, then stage equals render stage dot done. That way we'll be able to render this stuff all in order. We still need to set this up to be render stage albedo inside of the initial run call. So we'll go ahead and put that in here. There we are. The only thing left is why process map is red and process height map is red. Those shouldn't be red. Maybe I have a spelling mistake. Ah, there it is. So the basics are now set up. However, process height map is currently empty because alpha to normal is what we normally use. We're going to go ahead and use alpha to normal's functionality, and then we're going to go ahead and say debug.log error. Alpha to normal is not supposed to be called. So that should work out. I already know that we have to do a couple more things that we're not doing right now, but for now, we'll do it like this. And then instead of being y is greater equal to 0, y is less than height, blah, 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 we're going to use this limited y set. And that way we will have the ability to only do a small section of the y values that we need and do, one per frame. And that should keep it under control. We'll go ahead and hit save, and then we'll look over here, wait and see what sort of spelling mistakes I made. None, huh? All right. And then we're going to hit play. If we look at our Earth-like planet, stage none, it should immediately start to play, and it should change stages. Now, if I really want to make this work, what I'm going to need to do is actually get a noise field generator that's more optimized, because the Perlin's pretty slow. And now we're doing the normal map. You won't be able to see any normal map change, just because it's already there. But alpha to normal is not supposed to be called. Well, then who called it? Well, I can just delete it. So where are we calling alpha to normal? Here it is. Scan and pan counter equals 0. Process map. So then we're going to want to say run height map. Yeah, that's correct, right? Yes. Yes, that's correct. Well, see what's happening? So something is calling it over and over and over. In addition, it's getting initialized to some strange values, but that's quite odd. So it looks like run height map is getting called too many times, or perhaps it's got to be run height map. So we'll go ahead and put a debug in here. And then we will just go ahead and try and track down all the places that run height map is getting called. One is right there. One is here during update. But that's only when we run out during the albedo stage. Here is when we end up... oh, okay, so that's probably the problem. So here, we actually try and set up our height map like this, and that's obviously not going to work. So in order for this to work, we're going to want to actually go through and set all of our height map pixels so that we actually clear out the height map a little bit. So height map pixels for int a equals 0, a is less than height map pixels dot length. A++. Now the reason that we're doing this is because otherwise we'll end up with a random set of values as RGB has been taken up by other things. So we're going to preserve the alpha, and then the RGB is going to be changed. And we're also going to put metallicity.g in as the current alpha. And the reason for that is because we'll need the height, and we are in fact clearing the alpha when we process the height map. So metallicity pixels a.g equals height map pixels a.a. Store in metallicity g for use when building cities. And then we'll say height map pixels a equals, and we need a color that is a specific color for a neutral set of values. And so color 32 neutral equals new color 32, 128, 128, 255, 0, I think. So then we'll just go ahead and say that that's neutral, and then we will set our alpha equal to metallicity pixels g. See? So that should work out for creating a neutral height map. But we need to actually do this at the end of our process height map as well. That might work. Let's try it. Got any errors for me? No? All right, so now we're running and doop, doop, doop. That's still really slow, though. And there's our height map. It didn't finish. Huh. So if we hit randomize, we should get a new planet. Huh. Scan and pan doesn't seem to be working. That's odd. Let's go ahead and switch over to showing the hot planet, just because it's smaller and I can process it faster. In fact, I can process it so fast that it doesn't even bother to split it into pieces. Oh, that's because I've got this here, 16. Okay, so you can see that we've got a bug where it continues to be broken. If we take a look, it's clear that it's processing at 1 per frame, and it looks like it's running through all of the elements. The question is whether or not the elements of the height map are erroring on the first or the last. It looks like they're erroring on 0 to 1 rather than on 16, but that's hard to say. So what we can do is in the process, here in the render stage, we can actually go ahead and say debug.log. No, let's put it inside process height map. And let's go ahead and see whether or not we can get this to properly show what's going on, because I think that we're not calling certain numbers, and I don't know which numbers those are. Oh, once again, this needs to be 16. All right, so now we have it all set up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we are doing a full pass. I know what the problem is. I'm changing the alpha, and therefore it is overriding the alpha. See, previously I was doing this all in one go, but now that I'm splitting it apart, I'm getting dirty pixels. In fact, I probably was getting dirty pixels before and never noticed it. But that means that what I've got to do here is when I do this alpha to normal stuff, I have two options. Either I can leave the alpha as it was and see what that does, or I have to pull from the green channel. So I don't actually know. In theory, the alpha is not in use by the normal map. Once again, I forgot to fix this. Okay, so clearly the alpha is used by the normal map because that is hot garbage. So if I take the height map back here, what I'll just do is, rather than this, I will grab it at the metallicity pixels. Yep, that works. I am left with some questions as to its overall efficiency, but I don't see any problems with the normal maps. I kind of like how it makes no sense for a little while. Let's go ahead and see how long it takes to run a fresh batch. So you can see that the normals take, I mean, it takes a lot longer when there's this many options. I think that what we're going to want to do here is change our step size based on our LOD. So to do that, we're going to go in and set up our step size as a set of functions. So right now, one of the issues is that we set step size to 1 or to 0 or whatever, and then we set scan and pan to something else when we are rendering. But the problem is that we can't do that. So what we're instead going to do is have step size be a getter and a setter. So when we have it as a getter, we're going to grab the LOD level. So if we switch for the LOD level, then we can determine what sort of steps we want based on how large the element is. Yeah, I don't know why it's screwing up. That's fine. So if it's like this, we'll return, say, 32. And if it's like half, then we'll return 8. Otherwise, we will return 1. And then if we don't get anything, we'll go ahead and return 1. But we're also going to return 1 if we're not in play mode. There we are. So in that way, what we'll do is we will be able to quickly get these values without having to continuously set and reset them like we are now. However, it looks like I have an error in my brackets. There they are. So what we need to do is here, when we set the scan and pan counter to 0 and then we set step size to 1, the problem is that if we set scan and pan counter equal to step size, then having a step size of 1 will actually make it incorrect when it is doing that. So we're going to need to have one more thing to make this work. And their step size is here, public int starting scan and pan value. Get. If step size equals 1, return 0, return step size. So if we do that, then we don't have to worry about this. We can just say scan and pan counter equals initial step size, did I call it? Starting step size value? Starting scan and pan value. There it is. Scan and pan counter equals starting scan and pan value. There we are. And that should all work. It's not going to be any faster, but it's going to be a lot more easy to use. So right now we've got this issue where when we were running this, it was taking too long on the small stages and taking too long on the large stages. Now we can make it take shorter in both. So that was our shorter state, our smaller set, and our scan and pan was 8. Now it should be like 32, which should allow it to process pretty close to 1 per frame, whereas before it was quite slow. So that's best because it allows us to get a little bit of detail, and that's definitely going to work out to our advantage. There we go. So the question is, what happens when we flood our entire scene with stuff to calculate and hit play? That's actually not too bad for 4 simultaneous planets processing. and you're right now looking at the ugliest part of these planets. That's interesting. It looks like the two guys on the left are the same planet, like exactly the same planet, which shouldn't be possible. They should have different height maps and stuff. That's quite strange. Well, what happens if we randomize one of them? Do they both get randomized? No. Maybe it was just really bad luck. Huh. So here we've got a barf. So what we need to do is make sure that our texture pool, if it's null, we remove it. So if not pool, probably due to me being in edit mode, then we're gonna want to clear it. So we say texture pool dot remove at a. Actually, we can run this outside, can't we? Texture pool dot remove null. Except for I think that only works once. I think that just removes one null. So we're gonna want to actually do it this way after all. Oh well, should work. There we are. So now if we hit play... Oh, but it got stuck in albedo rendering mode, didn't it? The rendering modes during the instant render are a little bit broken. So we're going to want to go into the instant render and have it correctly say that it's done, right? Let's go ahead and take a look here. If we take a look at the moonlight and we run it, starts at stage none. We hit run. And it barfs? Oh, continue. Run. There we are. So that creates a new set of moon objects. These are all tinted by height, which is obsolete. We don't want that. Yeah, it's all good. So when we ran it, it ended up in albedo mode, and that's not correct. So you see how it gets stuck in albedo mode? We need that to not happen. So what happens is when we run it, it runs through process map super fast. It finishes up. And then it says a scanning pan counter equals 0. Then you want to set the height map pixels so that you get a cleared height map. And then you need to do this junk. Process height map. So it should happen here. So I think the problem is this update never happens with the run height map. So we don't end up with a height map. What we need to do is we need to have that actually happen much more aggressively. So here in run, not the one with the proxy, here. This should work. This should work. But for some reason it's not. So what we're going to do is at the end, we're just going to manually set the stage. We'll go ahead and set it to finished for now. We'll have to think about the best way to handle that because this edit mode nonsense is obviously a little bit odd. Well, that seemed to work. Good. So now if I hit play, that one alone won't change its rendering. Oh, I guess it will. That's interesting. Huh. Well, let's go ahead and spin all these planets back around because right now they are all facing a weird direction, which is bad. Nope. Hit play, and let's just see what it looks like now. All right, so that seems to work okay. There is some nonsense in how it gets rendered initially. You can see that really, really bizarre height map that pops up at the end there. I think that initially bizarre height map is there because we're setting the height map pixels back to alpha. So if we actually don't do that, it'll probably look fine. Let's go ahead and try it. And then once we've done that, I can start working on making planets pop, or cities pop up when you click. Yeah, that's much better. It's much better, except for the small fact that I think it's supposed to be 128 rather than 0. Maybe it's even supposed to be 255. I'm not actually sure, but we can find out. So what happens now is when you click on the planet, a city is supposed to sprout up. The cities are going to glow in the dark, and they're going to be sized based on the overall setup of where you've clicked. They're going to go through the place, look for the height map and all the pixels and stuff like that. And it should make it so that you can really easily plunk cities down on the planet. So here's with the click master. This places the city. So we're going to just go ahead and for now have a special function on our planet which allows us to write pixels. So public void set pixel color 32, or set city pixel, because it's specifically city pixels that we're going to want to do. And we'll just do it with an X and a Y, or a float, a vector 2 UV coord. And then what we'll do is we'll convert that UV coordinate over into X and Y values. So X equals mathf.floor to int UV coord.x times width. Int Y equals the same thing, but for Y, and height. I don't know why those are red. They shouldn't be. Oh, because they're on the click master. This is supposed to be on the planet, you idiot. I should really clean up the code here on the planet. There's a lot of stuff in it that I could move into various groups, but that's fine for now. So we've got int X and int Y, and what we're going to do is we're going to overwrite the albedo, but we're actually going to not. We're going to overwrite the color, the glow-in-the-dark elements. If we take a look, I don't know whether we save those emission pixels. We do not save the emission pixels, which means that we end up creating a lot of extra pixels. Let's go ahead and save the emission pixels as well. Just because otherwise we're going to have to do a lot of extra work. Oh, what the heck? What happened? It like jumped around funny. That was weird. All right, so that creates emission pixels. We still need to have them actually pop into existence. So emission pixels equals new color 32 size. And then what we'll do is we will go ahead and write those pixels and then change the values. So emission pixels X plus Y times width equals, we're going to want to have this be able to pass a color, equals glow color. And then we're going to say, here's the thing. We want to be able to set multiple city pixels, so we're going to have a bool suppress equals true. And what that's going to mean is that we're only going to call that if we're not suppressed, we'll go ahead and update the emissions texture. If we are set to suppress, we won't, and that way we'll be able to not update it dozens of times a frame. Sets an emissive pixel and optionally applies it to the emission texture. Do not apply to texture yet. Right, there we go. And so what we're going to do over here in the click master is we're just going to tell it to update that pixel. So we'll say planet p equals hit.transform.get type a get component planet p dot set city pixel. We'll pass it hit.texture coord and a glow color of just white. Right? Let's try it. Grind, grind, grind. Wait for these to finish processing before we actually click on stuff. Now over here, this guy's done already, and he has the correct object, so we could click on him. Let's go ahead and clear here. So I told it to update. Oh. False. I forgot that we actually do have to do that stuff. So we're going to go ahead and take this Earth-like down to 0.5, 0.5, 0.5, just so that everything processes a little bit faster at the moment. You don't need it to be high quality when we're testing this stuff. There we are. Now if I click, it should set it up with white pixels. Oh, they don't have an emission. Okay, so the planet doesn't have the emission set up, so it's not glowing in the dark yet. That means that we're going to want to turn on emission for everything rather than only for the thing that we emit. Here we say, if anything emitted, blah, blah, blah. We're going to go ahead and have that be universal. And then our create property block, we're going to take out that Boolean. The only question is whether or not that's going to play nice with... Oh, I didn't let it reload, did I? I guess I did. Hurrah. Yeah, so you can see that we can put down city pixels like willy-nilly, but it disabled the emission on the rest of the planet. What was up with that? Hold on. All right. What? So for some reason, the emission pixels aren't properly being saved. So they're all being set to black between us clicking and otherwise. So the emission pixels stop working in the middle here, and I'm not sure why that would be. Well, if we take a look at us checking on emissions here, that is done here. Metallicity pixels. If our metallicity of blue is something, then anything emitting equals true. We can get rid of that. So here's the problem. Our EMI pixels are what we're using. We need to change this out for emission pixels. So EMI pixels are not what we're using. We're using emission pixels. That should work. Let's try it out. Let it process for a bit. Hit play. Yeah, that's better. Now the thing about this is that every click is going to make it brighter and brighter and brighter, but that's kind of the point. On a more high definition map, it wouldn't glow as bad. So if we were to change this Earth-like back to being a full-size planet with a 1024 pixel limit, we would quickly see that the glowing is not going to be as overwhelming as it looks. See, it's not nearly as bad on a smaller, higher resolution situation. Now you might be saying, okay, some of those aren't glowing at all and some of them are glowing way too much. Yeah, that's going to be the issue with the way that this glows, but the good news is we're not planning on setting a pixel. When you settle, it's going to settle like a web of pixels, and it should be quite feasible and fun. It should look great. We will be using the planetary coordinates, and it should work out. So let's go ahead and just start everything up one more time here. Gonna go ahead and make the hot planet a full-size pixel thing too, and then just adjust it in the camera so that I'll just hit play. So if you got any questions, I would recommend you ask me them now because we're coming up onto the end of our stream time. I'm getting hungry. I might do a little bit off screen, but I don't know if there'd be a reason to. I have some more work I have to do tonight, so I don't know whether or not I'll do any more work on this tonight. We're making fine progress. I expect that we aren't going to have any problems completing in time. Yeah, it should be all good. And I should see you over and over the course of the week until this game is done. He says that I didn't fix the similar small planets on the left. Yeah, I'm not sure exactly what's going on over there, but it's not a high priority at the moment. It's not something I'm going to overlook. If it happens over and over again, I'm going to see it long before I publish. But it's worth taking in mind, you know? So, well, let's go ahead and post that. Did a whole bunch of optimization and made it so you can click planets. Tomorrow, making clicks deposit giant cities instead of dots. Procjam. And then we'll just pop over here and say the same basic stuff. Procjam. Okay, so thanks for stopping by, and I will see you tomorrow if you plan to come by again. Otherwise, I will just finish my job and then work on my game alone. Oh, I'm hungry.